Hi students, welcome to my channel Biochemics with Ajay Minor. Today we are going to discuss exclusively multiple choice questions from a chapter called The Human Eye and the Colorful World. Yes, in this video we are going to discuss 20 multiple choice questions which were appeared previous examinations, board examinations. So please don't skip this video. Watch till the end of this video. After watching this, please like it, share it, and subscribe it. Without wasting our time, we will start today's class. Here is your first question. A person went for a medical checkup and found that the curvature of his eye lens was increasing. Which defect is he likely to suffer from? My dear children, we have a situation here. A person who is suffering from some eye problem happened to visit a doctor. After primary checkups, a doctor found that the patient's eye lens was increasing. And what is the defect is he likely to suffer from? When eyeball increases, certain problem occurs. What is that problem? See this picture here. In the picture, in the first picture, for the eyeball, right, we can see the intersection of refracted rays occurred are focused in front of the retina. To correct this one, we used here lens, which is diverging lens called concave lens. If you use concave lens, and we can rectify that problem, right? Now let's see the options. Option A, myopia, short-sightedness. Option B, cataract, becoming a cloudy. Option C, presbyopia, which is age-related problem. Option D, hypermetropia. This is called long-sightedness. Your option is option A, myopia. My dear friends, see here, in myopia, what happened? The size of or the thickness of the lens increases. When thickness increases, the focal length decreases. If focal length of lens is decrease, then the intersection of refraction rays happen in front of retina. When intersection takes place in front of retina, a retina cannot recognize the image. So the person who has this problem cannot see image properly. To rectify this problem, we have to increase the focal length of that thickened lens. To increase the focal length of that lens, we have to use concave lens or convert diverging lens. This concave lens that increases the focal length to the retina. When intersection takes place at retina, then automatically image is formed on a retina. Here, retina acts as a screen. From the screen, signals will go to the brain through optic nerve. Then we can recognize image. So the answer for this problem is the person is suffering from myopia. It's a short-sightedness or near-sightedness. That means the person can see things close, near one, and he cannot see things from far. So correction for this myopia using concave lenses. Concave lens is also called diverging lens, right? Next question. A person gets out in the sunlight from a dark room. How does his pupil regulate and control the light entering the eye? Children, see, it's very strange actually. Whenever you come out of the room, from your room into sunlight, immediately we blink our eyes. We blink our eyes and we reduce and size of our eye also. That means the sunlight, which is high intensity, that cannot be afforded by our eye, since our eye is very sensitive, light sensitive. So immediately our eye try to reduce or limit the light entering into eyes. In this, pupil is the part that regulates and controls the light entering in the eye. How it does do? See the picture. If you see this picture, in the first picture, when you are in a bright light, you see the size of the pupil contracts here, pupil contracts. And if you see a dim light, like when you are in the room, the size of your pupil increases. What is the pupil here? Pupil is nothing but it's a hole through which light enters. Behind pupil, behind this one, we found a lens, convex lens in our eye. So here, this iris, pupil that decreases its size and it limits amount of light entering into eyes, right? Now let's see the options here. Option A. What happened when you suddenly come out of your dark room into sunlight? What happened? The size of the pupil will decrease and less light will enter the eye. Option B. The size of the pupil will decrease and more light will enter the eye. Option C. The size of the pupil will remain the same but more light enters the eye. And option D. The size of the pupil will remain the same but less light enters the eye. So my dear children, if you observe this picture, first picture, when you are in bright light, the pupil size decreases and the pupil allows only less amount of light enter the eye, right? Your option is option A. The size of the pupil will decrease and the less light will enter the eye. This is the answer for you. Third question. When light rays enter the eye, most of the refraction occurs at the dash, right? Most of the refraction. When light enters the eye, most of the refraction occurs at the dash. Option A, crystalline lens. We have a crystalline lens. Option B, the outer surface of the cornea. Option C, at iris. Option D, at pupil. Now, if you observe this picture carefully, my dear friend, my dear children, the outer blue color lines, two lines are there. That is like it's a cornea, outer layer of the cornea, through which light enters. From there it goes through the pupil. From there it goes through the lens. From there it goes through the retina. Now we'll see where refraction takes place. The refraction occurs maximum at the outer surface of the cornea. Refraction means what? Bending of light from its direction. When light moves from one medium to another medium, if these two are transparent medium, then light bends towards normal or away from the normal. If light moves from rarer medium to denser medium, the light bends towards the normal. When light enters from denser to rarer medium, the refracted ray go away from the normal. So here the refraction takes place at the outer surface of the cornea. Question. In which part of the human eye is the image of an object formed? Yeah, we already discussed that where image is formed in a human eye. And this image, this part also called as this resembles a film camera which we use in a cam, right? See here man standing in front of the eye. So rays are going through cornea, from there to lens, from lens to image is formed at image is formed at retina? Inverted image. Option A, iris. Option B, pupil. Option C, retina. Option D, cornea. Right? In which part of the human eye the image of an object is formed? Your answer is it's retina. Retina. You can see a man of image is formed inverted at retina. Question. The danger signals installed at the top of the tall buildings are red in color. These can be easily seen from a distance because see, why do we use red color at signal lights and tall buildings and towers, big towers and like mobile towers and all? We can see red color lights instead other than other colors. Why? Why we use red color? See here, the picture here, you see the top of the building. It's a tall building where you can see red light. Why do we use red light in this condition? Even at the signals also we use. Option A, red light is scattered the most by smoke or fog. Scattering means distribution of light in all directions. Option B, red light is scattered the least by smoke or fog. Option C, red light is absorbed the most by smoke or fog. Option D, red light moves fastest in the air. Now we'll see one by one. Red light is scattered the most by smoke and fog. My dear children, if a red light is scattered, then you cannot see red light at that point of origin. It spreads throughout the atmosphere, right? Now, option C, if red light is absorbed the most by smoke and fog, then we cannot see red light over there. Fourth one, if red light moves fastest in the air, then also it's not possible for us to recognize. But the correct option is B. Red light is scattered the least by smoke or fog. Right? Let's see the answer. Option B. Red light is scattered the least by smoke or fog. That means red light will not transfer. That will not move away from the source of origin. It will stay there. That's why it is easy for us to recognize that particular object. Question: which of the following phenomena of light are involved in the formation of rainbow formation? See this one, rainbow formation, that means splitting of white light into different colors, almost 7 colors. That is a phenomena. Now let's see a refraction, dispersion. My children, during a formation of a rainbow, 2 to 3 different phenomena take place at a time. Then only rainbow forms, right? So in rainbow formation, what are the different phenomena that take place? First reflection, then refraction and dispersion. Option B, refraction, dispersion and total internal reflection. Option C, refraction, dispersion and internal reflection. Option D, dispersion, scattering and total internal reflection. Right? Now let's see the answer. Option B, it's a refraction, dispersion and total internal reflection. How? See children, here incoming sunlight, white light, when it touches the water droplet, immediately it refracts. Immediately it refracts. Then white light splits into 7 colors. That is called dispersion. After that, after dispersion, those 7 colors, they reflect internally. Total internal reflection will take place. Then it comes out as a rainbow. So the three things which happen during rainbow formation are first refraction, then dispersion, then total internal reflection. Next question. A person sees an object closer to his eye. What changes will take place in his eyes? A person sees an object closer to his eyes. For example, if you look at an object from close, what will you feel? How will you feel? See here, this person is looking the book very close, very close. Now, what are the changes that will take during this activity? Your answer options. The pupil size will expand, the ciliary muscles will contract, the focal length of the eye lens will increase, the light entering the eye will be more. See here, what happened here? Your answer, the ciliary muscles will contract. The ciliary muscles will contract. The splitting of white light into different colors on passing through a prism is called dash. What is this called? Glass prism. When white light passes through a glass prism that splits into 7 colors, that is a process called option A reflection, option B refraction, option C dispersion, and option D deviation. Your answer is option C dispersion. So splitting of white light into its constituent colors when it passes through a transparent media like prism is called dispersion of light. Next question. The image shows a light ray incident on a glass prism. The various angles are labeled in the image. Which angle shows the angle of incidence and angle of refraction respectively? Now let's see the picture and then we'll find out what is angle of incidence and what is an angle of refraction. See this picture as a triangle prism is given here. An incident ray is given. We can see the arrow mark. You can follow arrow mark. The incident ray strike at the surface, one of the surfaces of prism, and after that it refracted. Now here we have to find out what is the angle of incidence and the angle of refraction. Clear? Option A and D, A and D. Option B, B and E. Option C, C and F. Option D, D and F. Now what is angle of incidence here? Angle of incidence is A, and angle of refraction is D. So your option is A. Option A and D. Next question. The deflection of light by minute particles and molecules of the atmosphere in all directions is called dash of light. In all directions, right? Deflection of light by minute particles like dust particles and all present in an atmosphere and molecules of the atmosphere, that means air particles and all. They just they just deflect light in all directions. This phenomena is called. If you see here the picture, there are some dust particles, atmospheric particles. They deflect light in all directions. If light bounces back in same direction, that is called reflection. If light bounces in all directions, that is called deflection. And this phenomena is called option A dispersion, option B scattering, option C interference, and option D Tyndall effect. Your answer is option B scattering of light in all directions by atmospheric particles is called scattering of light. Next question. Which of the following phenomena contributes significantly to the reddish appearance of the sun at sunrise or sunset? My children, we know that during morning time we can see sun in red color or orange reddish color, and evening also during sunset also we can see sun which is a reddish orange color, sometimes orange color. Why? What is the phenomena that makes the sun appears red during sunrise and sunset? See this picture. I think this is sunset. I think you can see sky and everything, even sun also that will look like reddish yellow, reddish orange like that. So what is the phenomenon behind this appearance? Option A, dispersion of light. Option B, scattering of light. Option C, total internal reflection of light. And option D, reflection of light from the earth. What do you think of this one? What do you think of this one? Your answer is scattering of light. Scattering of light. See, my dear children, in between sun and you, there are many particles present in the atmosphere. Some of them are gaseous particles, some of them are solid particles, moisture, liquid particles, different particles are there. When sunlight touch them, those particles, they deflect light in all direction. That is called scattering of light. Next question. Why do stars appear to twinkle at night? See this picture here. Twinkle, the stars are getting twinkled here. We can see actually in reality stars will not light like this. It's just like a tube light we can see in our home. They like. But generally we see this kind of appearance during night sky. Why? Option A, because the light of stars travels in a different medium. That means to reach that light from star to your eye, the light should pass through different mediums like dust, gas particles will be there, some liquid particles are there, some solid particles are there. So the light from star should travel through different types of medium. Option B, because the distance of the star varies when the earth rotates. Option C, because the star changes its position relative to the earth. Option D, because the atmosphere reflects the light at different angles. At different angles. Now your answer is option A, because the light of stars travels in a different medium. That's why stars appear to twinkle at night. Next question. When white light enters a prism, it gets split into its constituent colors. This is due to, we already discussed this question, and its different option A, different refractive index for the different wavelengths of each other. Option B, each color having the same velocity in the prism. Option C, prism material having high density. Option D, scattering of light. Now you see here, if you see this picture here, you can see wavelength as well as refractive index of particular color. The wavelength of violet is 400 nanometers and refractive index of is 1.34451. And next one, violet indigo, it's around 425 nanometer and its refractive index is 1.34235. Like that, as wavelength increases, then refractive index decreases. As wavelength increases, refractive index decreases, right? So why can we see a constant colors here? Different refractive index for different wavelengths. That means Since they have different wavelengths here, they refract at different angles. That's why white light can split into 7 colors. Thereby we can easily recognize all 7 colors as they have different refractive indexes. Right? Now we'll see the answer. Option A. Different refractive index for the different wavelengths of each color. This is the reason, that's why we can see a white light splitting into 7 colors when it passes through a transparent medium. Question: when white light enters a glass prism from the air, the angle of deviation is least for angle of deviation. See here, white light is entering from air, that is a rarer medium to a glass. This is the denser medium. Then what happens generally when light enters from rarer to denser medium? It refracts and it bends towards its normal, right? The angle of deviation is least for what? Angle of deviation when wavelength is less. Now we'll see that one. Option A, blue light. Option B, yellow light. Option C, violet light. And option D, red light. So the angle of deviation is least for the one which is having low wavelength. Your option is high wavelength. Your option is red light. Red light. Your option is red light. Red light deviates least. It deviates very least. So that's why we can see red light very easily. Next question. Which option justifies that the sun appears red at sunrise and sunset? This question we already discussed. Option A, red scatters highest by the atmosphere. The distance between the sun and the earth reduces. Red has a high wavelength, so it travels a longer distance. The white light disperses into 7 colors. Only red enters the atmosphere. Your option is option C, that is, red has a high wavelength, so it travels a longer distance. That's why we can see a red sun at sunrise and sunset. At afternoon, the sun appears white because, see this picture here, sun appears white. Sun appears white because light is least scattered. B. All the colors of white light are scattered away. C. Blue color is scattered the most. And option D. Red color is scattered the most. See, my dear children, here during afternoon time, we see sun appears white. This is the reason here is the distance between earth and sun decreases during afternoon. But during morning and evening time, the distance between sun and earth increases. When there is a less distance between sun and earth, the white light cannot disperse faster. That's why it looks like white. Now let's see the answer. Option A, light is least scattered. Light is least scattered. That's why it appears white. Next question. Twinkling of stars is due to atmospheric: A. Dispersion of light by water droplets. B. Refraction of light by different layers of varying refractive indices. C. Scattering of light by dust particles. D. Internal reflection of light by clouds. Your option B. Refraction of light by different layers of varying refractive indices or refractive indexes. Question. The image shows the dispersion of white light in the prism. See here, the prism here, a white light dispersed into colors. Generally it disperses into 7 colors, but we have given 3 colors there: X, Y, Z. X, Y, Z. What will be the colors of the X, Y and Z? X, Y and Z. My dear children, you remember this one. When light passes through a glass prism which is kept normal, the topmost color is red color and the lowest color is violet color. Right? Topmost color is red color and down color is violet color. So option A, X is red, Y is green, Z is violet. Option B, X is violet, Y is green, Z is red. Option C, X is green, Y is violet, Z is red. Option D, X is red, Y is violet, and Z is green. Your option is option B, X violet, Y green, and Z red. Remember, red is always top, whereas violet is down, normally. If you reverse this one, violet will be topper and red will be down. Right? If you see here, red is top, violet is down. Red refracts least, whereas violet refracts high. The one which moves with high frequency, low wavelength, that refracts well. Next question. Which of the image shows the deviation of light in a prism? In a prism. A, your answer option B. See the option B. Incident ray is coming from out of slanting to the surface. After that it refracted. After that again it refracted as an emerging ray. Incident ray, refracted ray, emergent ray. Option B is the correct answer. Option B. And the last question. The image shows the ray diagram of a defective eye. The first one, see this one, right? This is the defective eye. Which option shows the correction of the defect of the given eye? See option A here, you can see some concave lens is used, and option B also concave lens is used, and option C convex lens is used, and option D also convex lens is used. Now let us analyze these options. My dear children, if you look at option A, incident ray is coming from outside. It is shown by arrow marks, right? After passing through lens, so there is no arrow mark at all, right? In option B, after lens also you can see arrow marks. Option C, after lens also arrow mark. Option D, there is no arrow mark. But in option D, if you see option D, the intersection of refracted rays, they are exactly happening on the retina, right? So your answer is option D. Option D. In option D, you see here, option D, if you see here, those two refracted rays, three rays, they are exactly intersecting on the surface of the retina. This is the place where image is formed. So this is the option that the person has to choose to get rid of his defect. So my dear students, these are the questions today we have discussed. I think most of you understood how to solve MCQs with related to human eye. These are the most important questions and previously appeared questions here, and I think I explained clear. If you have still any doubt, please message to me in my comment box. Thereby I will try to give answer. After watching this, Please like it, share it and subscribe it. Thank you.